Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this video we will discuss about one of the amazing concepts in DSA which is so far missing in the playlist of DSA using Python, and many of you have requested to cover up that concept as well. So for those who are not aware, I am taking a paid course live in DSA per se on my website techforallwithpriya.com, and that's where I have covered up very recently this topic of backtracking. And in the upcoming part of the clip, you will observe that I am attaching the recording for that particular live session. Please try to carefully check them out. Please try to understand the concept of backtracking. I have tried to make you guys understand the concept of backtracking via one problem, which is an application of, again, backtracking, Sudoku Solver. Very famous problem. How and at what point of time we should go for backtracking approach. Everything I am covering up. It's a very long session, so requires a little bit of patience to understand the concept. But before going towards the upcoming part, please make sure you hit like button. Please make sure you will share this video with each and everyone. Please make sure you will subscribe to my channel. Few days back, again, I was watching my stats of my YouTube channel, and the 60% audience is the one who is watching the content but is not subscribing. So my humble request is, please do subscribe the channel, and these kind of videos requires a lot of push from your side, from the audience side, so that it will be reachable to maximum audience, because it's a very conceptual videos. Coding is there, it's not kind of a vlogging thing which I am doing here. So I hope that you understand my point. It's an educational content that is also free of cost in a quality manner. So please make sure you will try to help me out in terms of approaching this video to the wider range of audience. So with this, without wasting any time, let's start the video. Let's move ahead with respect to the most important part, which is about backtracking. See, until so far, we have discussed a lot about recursion concepts, right? Backtracking. Now, I would say that if in this particular live session, there is anyone who is not at all aware about recursion or have missed the class of recursion, is not at all having any idea about recursion, you can skip the class also. Okay? You can just exit out of this class, because recursion is the most important fundamental of upcoming concepts in DSA. When I'm saying upcoming concepts, even in the next week, I will say the same statement. If there is anyone who is not good with the recursion, now onwards, they will not able to understand any further concepts of DSA. Whether it's a backtracking, in the upcoming week, we will talk about divide and conquer module. Everything and anything now will lie on this concept of recursion. Okay? So again, backtracking is a very important concept which lies above recursion. Again, application of recursion is, you can say, backtracking. What does that meaning? At what point of time we should go for backtracking kind of approach? Let's discuss that point at the very first scenario, and then we will discuss few problems on top of that in order to understand the applications of backtracking. Okay, perfect. So the very first thing, I'll take one simple mathematical example to demonstrate you how backtracking will work, and then we will move ahead, okay? Let's say I'm saying that in my class of DSA, I will be having 3 students. And out of these 3 students, the 2 students are having a gender of boys, and the last is one a girl, G1. Okay. This is a kind of a distribution of my class students' gender that I have. Now, in this particular case, what are the possible use cases for them to sit? Like how they can sit in a class physically? What are the possible use cases that we have? Maybe I'm saying that, first of all, boy is coming up, B1. After that, there can be other use case where either boy 2 will come up or girl 1 will come up. If let's say boy 2 will come up, at the very end, girl 1 will come. If girl 1 will come up, at the very end, there is a boy 2 will come. Or I am starting directly with the boy 2, right? After that, again, there can be two possibilities. What are those? B1 will come. After that, finally, G1 will come. Or let's say G1 will come, and at the very end, B1 will come. Or at the very start, G1 is sitting, and after that, B1, after that, B2. Or B2 is sitting, after that, B1. In total, how many possibilities are there? How many combinations are there to sit these three students?
6.
Does everyone agrees with me? It's 6, right? Mathematically, how this 6 number will come up? Permutations and combinations. How many of you know these fundamental concepts of maths? This is 3 factorial, right? Initially, first student has 3 ways, then second one has 2 ways, last one has only 1 way. 3 into 2 into 1. We have 6 choices, 6 ways. So whenever we will be having multiple choices, to do any task, that's where we will always opt for the concept of backtracking. One very important thing is that backtracking always gives us a brute force approach. What is the meaning of brute force approach? Very naive approach, where I want to explore all the possibilities and I want to print the answer of all the choices that I'm making. Okay? Now, out of these brute force approaches, let's say I'm saying that I want the most optimized approach. From all these brute force approaches, whichever path you're exploring, all the possible paths, if I'll say I want the most optimized approach, I want the most optimized path or the choice, that's where, again, dynamic programming will come into picture. So dynamic programming or DP will also do the similar task. DP will also explore all the possible paths that we have for a given problem, but it will give me the result of an optimized path, means which is having a lower time and space complexity. But when I'm talking about backtracking, it is not focusing on this aspect. It is focusing on giving all the possible, paths that we have, all the possible choices that we have. For example, in this case, we have 6 choices. So it will print me all the 6 possible choices. We can also add one condition on top of this. I'll take question. Just let me complete this point.
Yeah.
Let's say if I'm saying that, there is one condition that a girl cannot sit between 2 boys. Let's say this is a constraint. I'm writing it down. This is something that we called as a bounding function in backtracking. A constraint, a bounding function that a girl cannot sit between 2 boys. That's where now I am looking for this constraint, and under this constraint, whichever path is violating, I will remove that path. I'll remove that path. So for example, in this particular example, what are those conditions? What are those combinations where this particular condition is violating?
Two.
So what will happen? It will go to B1. What is the first answer? B2, G1. This is fine. Now I will go back. It will return the answer as true. I'll go back further. It will return the answer as true. This is fine. Now again, B1, then G1, and then B2. Now it will check it out. this condition is violating, right? G1 is between this B1 and B2. So it means that here I'll return the answer as false. I'll go back and this path will not be possible now. For the B2, again, it will check B1 is there, G1 is there. It is following the bounding function that we have. Again, it will go to the next cycle. It will return the answer as true, true, right? Now, again, it will go back G1 and then B1. So here, if you will be able to return the answer as false, because again here, G1 is the thing which is in between the boy B2 and B1. So this is not a possible path. After that, it will go to G1, then B1, B2 is right, then G1, B2, B1 is right. Now, if I'll ask you how many possible combinations we have, the answer will get changed from 6 to 4, right?
4.
1, 2, 3, and 4. So the possible answers are, now in this case, the possible answers are B1, B2, G1. Second case is B2, B1, and G1. Third case is G1, B1, and B2. And the last case is G1, B2, and the B1. So these are the 4 interesting, use cases that we will be able to find out via the backtracking. So what is the meaning of backtracking? You are moving from the top to the bottom, then going back, returning either true or false, depending upon what is the bounding condition or the function that you have. Either it will be true or it will be false. Whatever constraints it is following, it will be true. Wherever it is lying, it will be false. So always remember, important thing, backtracking always gives us a multiple choices. Wherever I want to explore all the possible choices that we have, that's where I will go for a backtracking approach. It will always give me a brute force approach result. It will not work upon an optimized approach. If I want to go for optimization, that's where dynamic programming will come into picture, which will explore all the possible paths, just like the way backtracking will do, but will give me an optimized result. When I'm saying optimized result, the simple meaning is I want to have a lower time and space complexity. That is where DP focus, not backtracking. It is having bounding functions. What is the meaning of that? Some constraint is given to us. For example, in this case, the constraint is that girl never sit between 2 boys. This is the constraint, and depending upon that, our result will get changed. Yes. Now ask the question with respect to whatever points just now I have discussed. If anyone is having any issue.
Okay, it was clear. Like you took the six ways. So I was thinking of which, like upon which basis you are taking 6 ways. So I understood that you're taking the low, extreme node, right? The low, like I can see
Yes.
1, 2, 3, 4, 5, 6, right? So I was
Yes.
confused with that.
Yeah.
So there are so many circles out there now. That's why.
Now it is clear?
Mhm.
Okay, perfect. Any other doubt anyone is having?
So if I'm understanding this correctly, backtracking is basically one level of optimization over recursion, like pure recursion, or am I?
Backtracking is? Repeat your point.
So backtracking is also a part of a recursive approach, right?
Yes, definitely.
So
it's a part of
I mean,
recursive approach only.
So there's pure recursion. I mean, where we explore all the conditions irrespective of whether it is beneficial for us or not. So here we are just applying one level of optimization over it, where we prune out some paths before they even compute fully. Is it, like it's an optimization over recursion? Can we call it?
Correct. It's correct. Any other doubt anyone is having? So it's a recursion only. You will observe that when you're writing this code of backtracking, you will use a recursive call only in order to implement that. And even the further concepts that, as I told you, that we discuss in the upcoming week, all those are applications of somehow recursion only. There is a recursive code which will be going on internally to get the results.
Hello, ma'am. If you don't mind, I understood this. No, I mean, told us taking the combinations and bounding function, can you please explain the last 2 points? I mean, you told us about backtracking.
What are the last 2 points? I don't even remember.
When you were saying somewhere like from bottom to top, right? If I'm not
Okay.
sure.
So here, basically what we are saying is that we are, how basically in recursive tree, we scan our tree. We start from the top. For example, how we scan this particular thing. We start from the top. Left side, first of all, you will scan. B1 is there, then B2 is there, then G1 is there. Then you will check that this bounding function, is that following this path? Yes. Then you will return the result as true. And when you return the result as true, that will be your under your final result, final answer. After that, you will scan the next particular entire node from the start to the leaf node. So B1 is there, then G1 is there, then B2 is there. Again, you will check this bounding function. Is that following this particular path? No. So you will return the answer as false. False. So this path will completely get neglected because this particular constraint which we have mentioned, this is not following. G1 lies between two boys, B1 and B2. That's what I'm saying.
So
Just
we
like
can
the
say
way
that
we
from
scan a recursive tree, last time also we did, right?
so we can say that from top to bottom, bottom to top, right?
Yes, from top to bottom we go. We check the condition. If it is it says yes, the answer will return as true. Otherwise, it will return as false. If it is returning as false, we are removing that path entirely.
got it, man.
In last class, you explained n to the power of x. I think that was x to the power of n. Using divide and conquer, it will give result at the end of the tree. Backtrack to the upper node. Is that example of backtracking? Yes, this is recursive. Recursive tree always scan like this only. It's not the first time I'm explaining this. We always start from the root node, then we move towards the leaf node, then we move back to go to the further sides of the tree that we have. What is the meaning of backtracking versus normal recursive code is that when we're talking about recursion, for example of factorial, example of Fibonacci series, what usually happens is that there we have some fixed conditions. Here, in this case, we are exploring all the possible paths. In the normal recursive code, we are not doing that kind of mindset that we need to explore all the possible paths we have. Whatever questions of permutations and combinations that you will be able to get in an interviews, chances are very high that they want you to explore the concept of backtracking. Backtracking concept uses recursion to implement their code. Okay. So whenever you want to explore all the possible paths, that's where two options are there to implement those things. So I am again repeating my point. What I am saying is, in a question, whenever you need to explore all the possible paths, in a question, you need to explore all the possible paths. Means there are multiple choices that we have. In that case, in DSA, we have two options to implement. One way is the concept of backtracking, where we will try to see all the possibility. Another thing that we have is dynamic programming. Only these two things are there. Dynamic programming. Achha, there is one more thing also. Let me take that also into encounter. There is one more term which you will see, branch and bound. I'll take this maybe on later part, but as of now, these are the three options that we have: branch and bound, backtracking, and DP. Recursion is the algorithmic way, simple concept where function is calling itself. But algorithmically, this is the way, this is the way, or this is the way. This backtracking will give me a brute force approach. When I'm saying brute force approach, you will observe that almost all the applications of backtracking will give you an exponential time complexity. Exponential time complexity. And you all know that whenever we are saying exponential time complexity, it is very, very high. And this DP will always give you a optimized result. When I'm saying optimized result, here you will observe that the complexity will be a polynomial time. When I'm saying polynomial time, it can be linear, it can be quadratic, it maximum linear time complexity or quadratic time complexity. I don't think it will go more than that. When we will discuss DP module, you will get that point. So that is the way. When I'm saying backtracking, we usually try to explore our possible paths in the form of depth-first search. In the graphs, we have two ways, depth-first search and breadth-first search. I don't know how many of you are aware. For example, in this case, what I told you, we start moving towards B1, then B2, then we move G1. Then we will move back. Then we move to G1, B2. This is called as depth-first search, where I am first of all going below the depth. First of all, one depth will be covered up, then I'm moving towards another part of a subtree. So backtracking always tries to cover up all the possible paths in a DFT manner, depth first search manner. When I'm saying branch and bound, it works under the same category, just like a backtracking copy of that. The only way is it tries to explore the possible paths in the form of a breadth first search. That's the only difference. What is the meaning of breadth first search? Anyone, any idea?
Level order transfer.
Level by level.
Yeah, it's nothing but level wise, level order. Meaning in that case, let's say if I'm moving and exploring towards the branch and bound approach, I will go first of all B1, then I will go towards B2, then G1. Then B2, G1, B1, G1, B1, B2. Third level. Fourth level is G1, B2, G1, B1, B2, B1. I hope you're getting my point. So the way you are exploring your all the possible paths, depending upon that, the naming convention will get changed. If you're exploring in terms of depth wise, going from the first of all root to the leaf, just like that, B1, B2, G1, just like the way I'm saying B1, B2, G1, this is what backtracking does. If you're going level wise, branch and bound does. Both of them will give me a brute force approach results answer. DP is the only approach that will provide me a most optimized result under given constraints. That's why the complexity of DP is very, very low as comparable to the other approaches that we have, which also does the similar task of exploring all the possible paths, but DP gives me the best result. That's why in practical implementations, if you will ask me, DP is the one which is working almost everywhere, dynamic programming. Very important module. The last week, we will dedicate only to this particular module only in our complete live session classes. Is this clear? Shall we move ahead?
Yes.
Let's try to do one example, one application of this, and maybe with that application, you will get a better clarity of how these things are working on. Okay? Let's try to understand how many of you have solved a game of Sudoku? I think everyone must have in their life. Sudoku game solver. Have you?
No, I tried, but I couldn't.
Okay.
Or I didn't have the patience actually.
Okay. Apart from Arijit? No, okay. Is that so? I thought that many people will say yes, that's why I have picked up this problem. Okay, my bad. Let's try to explain to you. Let me try to explain to you. And then maybe from tomorrow, pick up some newspaper and solve this. It's very interesting, game. So I remember when I was in my school time, so newspaper used to come in the morning at my home, and my father used to, play this kind of thing. He really likes that. So I used to sit with him, and then from there I got this kind of a game. It's in very lower classes. So let's try to understand. It's a very interesting game. Write a program to solve a Sudoku puzzle by filling the empty cells. So what this game says, there are some rules that you have to understand in this particular game. So we will be having a matrix of 9 cross 9. Okay. What they are saying is that each of the digit from 1 to 9 must occur exactly once in each row. So for every row, you can't repeat the same number. For example, 1 cannot be repeated if it is already there. 2 cannot be repeated if it is already there, row wise. Same thing will happen for the column wise as well. So you can't repeat the same number in the entire column as well. Okay. After that, this is the second condition. Each of the digits 1 to 9 must occur exactly once in each column. Okay. The last thing, each of the digits 1 to 9 must occur exactly once in each of the 9 3 cross 3 sub boxes. What does that mean? So let me do one thing here. Let me just copy and paste it on my editor. Right? This is good. Now, what they're saying, the last constraint is this sub boxes that we have, 3 cross 3. Just make sure you will take this 3 cross 3 only, not 4 cross 4, not 5 cross 5. In this 3 cross 3 also, for example, this is the one. Then another one is this one. I hope you understand my point. Then the next one is this one. So for every particular, 3 cross 3, you will be having for each row 3 boxes, 3 cross 3 wise. So in this 3 cross 3 also, you will be having a unique number. Means, for example, if 1 is already there, you can't repeat 1 here. So there are 3 conditions. I hope these conditions are clear to everyone, because if these rules are not clear, then we will not be able to play this game. What is the first condition? Row wise, we need to focus that 1 to 9, all elements are unique. All elements are unique, row wise. For example, let's say if I'll add 1 here, so I can't add 1 again here. Make sure this is something which we have to understand. After that, second condition, the same thing, but column wise you have to make sure. Column wise, what I'm saying, again, 1 to 9 elements are unique. And the third thing, sub boxes wise, 3 cross 3 sub boxes that we can create. That's where again, all the elements are unique. Is that fine? 3 constraints. Any doubt in this part? Anyone? Now what we have to do? In our code, we have to write a code to fill all these blank numbers that we have. Okay? So this is the real thing that we have to do. For example, here if you will be able to observe in this question, this is the input board which is given to us. And this is the output which we will be able to get. If you will be able to see in this red colored output, if you want, you can also open in your screen on the lead code. What you will be able to observe that these numbers, if you will see all these numbers, will be actually unique in terms of all these 3 ways that we have discussed. The question is how we can solve this problem. Anyone, first of all, the problem statement is clear to everyone? Is it clear? Yes?
Yeah.
How we will
Scroll up.
solve them?
Okay. So the only thing that is coming to my mind currently, because I have kind of stayed away from this 2D type of questions So one is row wise and column wise, right? So let's say that we iterate row wise. So we have to maintain a sum for sure, like say row wise sum. And for every element we add to the, I mean, for every element we place, now I don't know how we would place that, but I'm guessing like that array ij something we will do. And for every element we place, we have to ensure that the sum doesn't exceed, I mean, I'm guessing the sum should not exceed the sum of 1 to 9.
Okay.
I don't know if that's making sense.
Some is something which you are focusing a lot.
No, not sum then. Sorry. I mean, that set of integers or numbers. Like it's not there.
One thing is, which I think everyone should be able to understand here. What is the target to achieve? Basically, you have to write numbers here. Like, what should be the number I should write here? For example, 1 or 2 or 3. So you need to fill this. Let me just bring out the output also so that you guys will be able to understand what we really want to achieve here. This is important to understand that what you want to achieve, what is the target value you want to get. Let me just copy it up and paste it here. This is what we want as an output. This is the input given to us, or user will enter this input, this 9x9 matrix, and this red mark color which you can see is the expected output.
Ma'am, can we use XOR here, ma'am?
Can we?
Can we use XOR operation to find missing elements?
No. See, you can't use here XOR or addition of these, whatever Ajit have said. See, think over it, because it's the very first problem. It's okay. Just try to, understand what I'm trying to convey here, and let me know whether you got my point or not very clearly. We will try to spend most of the time in today's class on this problem. And then as an assignment, I will give you one more interesting problem of chess. Everyone played chess at their home? Or
Yeah.
at least you
Yes.
guys know the rules of chess? So
Yeah.
if there is anyone who is not aware about that, we will discuss at the end of the class, and then I'll give you one interesting problem of chess also. Okay? So let's try to understand this. One thing is very sure, that let's say ki for this particular point, let's focus on first particular point in first row. There is a possibility of coming 1. So I will explore the first path where this matrix contains 1. Right? Now, whenever I am inputting any of the value, for example, 1 here, I will keep a check of these 3 conditions at every point. And I will check that writing 1 is safe or not, or is valid or not. I will try to create one function, maybe by the name of isValid, which will take the matrix board that I have, 9x9 board that I have, which will take this value of I and the value of j, which is in this case, let's say 0, 1, 2, 3, 4, 5, 6, 7, and 8. 0, 1, 2, 3, 4, 5, 6, 7, and 8. So in this case, we will be having I value as 0 and j value as 2. And the number which I want to insert, which in the string form I'll convert, it will be C character, which is, as of now, I want to insert the number as 1. So what I will do is I'll take a check that is this valid or not. How will I make a check? I'll check that is this 1 is available in the row. If I'll just cover up entire row, is this 1 is available? No, that's fine. Is this in the entire column 1 is available? No, that's fine. I will move ahead. Is this entire 3x3 subheading that I have, subbox that I have, 1 is available? No. So as of now, it seems one possible path in the recursive tree, in the backtracking tree, to have this 1 under consideration. So this is a one way which I can opt. So what I will do is, I'll try to take, now the only thing is to create these kind of metrics again and again. This is big one, right? Let me just copy this again. So what I'm saying is that how my tree will look like. This is the thing that I have. I'm pasting it again further. So one possible path will be, which is valid also, to place 1 here. Yes or no? Is this fine? Another possible path. Now let's start working upon with the next value. Next number, which is 2. If I'll place 2, is this valid? Is that can be the next possible path? What I told you, in backtracking, we try to explore all the possible paths. So when I put 2, is this valid? Again, we will check these 3
Yes.
conditions. This is valid. So the second possible path can be, in our code, we will write as this one, where I'll copy this again and I'll say this writing a 2 can be the next possibility. Next possible path. Can I write 3 and check is this valid or not? 1 is done, 2 is done, 3. Is this valid?
No.
No.
So this is valid function will give me the answer as no. So I will not move ahead. This cannot be your next possible path. 4. Is there a possibility of 4?
Yes.
Check again. Row wise, column wise, this sub box wise. Yes, right? So the next possibility can be that we will go for this particular part where I will be having a value as 4, exploring all the possible paths. Let's move ahead. 5 is valid. No, right? 5 is already there. 6. 6. No. 7. 7. No. Okay. 8. No. 9. No. Again.
Priya, like 9 is not in the entire that row and column, but
It's there in the third condition will get true, right?
okay,
In this
I mean,
sub box, it is there.
okay.
Right? We have to follow these 3 conditions. This is the condition of Sudoku. And there is and, not or. All these conditions should be acceptable.
Okay.
Now, one important thing which you will observe from this question is, again, try to go back with respect to the knowledge which I gave you a few minutes back. In backtracking, we are exploring all the possible paths and avoid those paths which doesn't follow my constraint or bounding function. So in this case, again, in this Sudoku solver, we are exploring all the possible paths from 1 to 9 and avoid those paths which are not following my condition. Yes, row wise, column wise, and 3 cross 3 sub boxes wise. So this is the 3 ways that as of now, which we are seeing. Now, further, we will move ahead to the next possible path. And let's say, again, we will check for the next possible path. Can we write down the 2? We will again check the same thing. If let's say I'll write down the 2, is that yes, fine? If it is yes, then what we will do? We will create further subtree here and we will say that 1 is already there. 1 is already there. Now we are saying 2 can be the other possibility. Then again, is 3 is feasible? Is 3 is feasible? No. 4 is feasible? 4 is feasible?
No.
No. 5 is feasible?
No.
No. 6?
Yes.
6? Yes. So another path will be, if we just say 1 is already there. And we are saying 1 is already there, 6 is the possibility. Then next is 7 is feasible? No. 8 is feasible? I think no. 9 is feasible?
No.
No.
No. So basically, I hope you're getting my point, what I'm trying to convey here, that in this way, for all the entire numbers we have, we will try to fill these data points. We'll try to fill these data points. And what you will observe that at the very end, there will be few data points which are wrong path, where the value will become, after backtracking, false condition, where you will not fill up any data point. For example, let me try to fill up few things and then I'll again come up with this thing. 5, 3, 6, because it's very huge. Let me fill up few data points very instantly and then I left few data points here. Or maybe 5, 3, 6, 7, 2, 8, 5, 9, 4, 2, 6, 7, 1, 3, 9, 6, 2, 8, 7, 3, 4, 5, 2, 8, 6, 5, 3, 7, 9, 2, 4, 8, 5, 3, 7, 6, 1, 3, 4, 2, 6, 7, 8, 9, 2, 3, 4, 8, 5, 6, 7, 4, 2, 3, 7, 9, 1, 8, 5, 6, 6, 3, 5, 1, 7, 9. Let me take it as blank. I have intentionally picked up only few data points which are missing now. Okay? Basically, what happens, this will keep on exploring for all the possible paths and this tree will be very, very huge. Okay? Let's focus on the smaller part of the portion where, let's say, row-wise, if I will scan. 1, is it possible? No. 2, is that possible? Let's say here also 1 is not there. Then it would be very interesting. Now, is this 1 is possible for this tree? Think over it. 1, is this possible now? Consider that these green numbers are also available for you.
Yes.
Yes, right?
Why is possible?
So what we are saying, that one possibility will be that, this will come. Make sense? Acha. In this case, is this 2 is possible?
No.
3?
No.
4?
Yes.
Yes, right? So another possible path will be to write 4 here. Yes? To write 4 here. Now let's move ahead with that point. If let's say Here, 1 is already available. If let's say 1 is already available. So the only factor which is left is, what value should I fill if 1 is the correct answer? 4, right? 1 is there, 2 is there, 3 is there, 4 is not available. So what will happen if I will fill up 4? Is this valid?
No.
So is this complete path is valid? Is this complete path is valid?
No.
That's what I'm saying. If you will traverse the above bigger one tree that you will be able to get in this case, because we have multiple gaps, you will feel that after some point of time, maximum paths or almost all the paths except one will return you the answer as false. Why false? Because when I'm making this as 4, it violates my condition. This is not valid. It means I have to go back and I need to make it empty again. So when I'm backtracking, I'm going back. When I'm returning false, I will make sure that I will empty this space, which I have filled with 1, because this is not the correct one. So when I'm moving back, I will make sure that I will empty this space. So there should not be anything available in this particular part. Is this part is clear to everyone? This is what I actually want to convey to you in the above part, because that is very big. That's why I have taken very small example to convey the same thing. But in this case, if you will be able to observe, if I write only 1 is left, is this correct? Is this correct? If you will see, 1 is the thing, row wise, column wise,
Yes.
it means this is the valid path, which is true. So with respect to this possible path, now I will move ahead with respect to next point. With respect to this point, what should I fill? Which is 1, because 1, apart from 1, everything is available, and even all those 3 conditions will be lying. Similarly, if I'll go with respect to this path, what do you think?
1.
Let's say 1 base, we can fill 1, right? If I fill 1, you will observe row wise 1 is not available, column wise 1 is not available, and even subbox wise 1 is not available. Can I put 2? No. 3? No. 4? No, because in this 3x3 submatrix, value is available. 5? No. 6? No. 7? No. 8? No. 9? No. So this is the only way we will be able to get the result. The final, this one, what is the last?
4.
4. So this is how basically we will try to explore all the possible numbers from 1 to 9. When we are inserting any number which is between 1 to 9, we are checking that for that number is the path is valid by making these 3 conditions verified. If it is valid, we are moving ahead to the next possible path, next possible use case. What will happen? For few paths, you will observe, for example, this 1 wala path. This 1 wala path, after some point of time when you will go down, you will see this kind of situation, which just now we have observed, where we are left with a 4, and when we fill 4, we are seeing that it is not a valid number. Make sure when you backtrack, I'm again repeating, it's not valid, so you will remove all the previous data points also. Make it empty. That's the important thing when we are doing a backtracking, because this is not a valid path. So whatever values we have inserted here are also not valid. Is this clear to everyone? Any doubt before I'll try to do the implementation for the same with respect to whatever points I have conveyed?
Yeah, understood, Priya, but it may take some time to grasp this thing, like whole
It's okay.
backtracking concept.
You guys can take your own time. It's not, it's completely fine. Let me try to, work upon the implementation part. See this as well. And then I will try to show you one platform where at your home, you can try to do it manually and check everything, whether it's how it is working. Okay. I'll show you each and everything. because these topics are comes under the category of, I would say, intermediate to advanced category, not easy to intermediate category. So it might take some time if you are a beginner, but if you will spend your own time after this session, I'll make sure that you will be able to get this concept very clearly. Okay, take it step by step, take it very easy. So what we are trying to do is, we are trying to solve this Sudoku. So what I will do is, I'll try to create one function by the name of a solve, where I'll take this board. What is a board? Board is this 9x9 matrix. Now what I have to do is, I supposed to majorly traverse all the elements. So how we can traverse all the elements in the two-dimensional matrix?
Loops.
Two
M
loops are
into N.
required, right? One is row wise, another one is column wise. So for I in range, length of board, which will take the number of rows, and then for j in range, length of board of 0, which will take the number of columns. So far so good? So far so good? What condition I will apply? If my board of I, j, at any point of time, you see it as an empty. Now here you can see that in my input, we are making this empty as dot symbol. So it's a string by the name of dot. Okay? So this is what we are doing. So what it indicates? It indicates that at any point of time, when you see that board is empty. So what we're supposed to do at that point of time, when the board is empty, what we're supposed to do? What we are doing in the theoretical understanding, what we have observed, we are filling the numbers starting from
1,
1 to
9.
9.
9. And one important thing, that these numbers, because it's a string, every number is a string, right? Can you see double quotes they're mentioning? So we will also convert our numbers into a string. Make sure, don't do this mistake, otherwise you will face a trouble. So what I will do, I'll say for C in, I'll start from 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll take the numbers starting from a string 1, will go until the value of 9. For every number, what we are doing, if let's say the number in the very starting is 1, what am I supposed to do? You just tell me logically, I will convert it into a code part. Logically, what you have understood, let's say initially my string C will take as the value as 1. So what we are doing logically?
Check it in row and column.
Repeat.
We will check it in row and column, and then in entire 3x3 subbox.
Yes, it means what she wants to convey, we are taking the condition that, let's say if we're taking a number 1, is that valid or not? 2, is that valid or not? 3, is that valid or not? Yes or no? So as of now, I will try to take one function is valid. We will define it later on. But this is what we are doing. Is valid is a function where we will take that board completely. Sorry, this is a parameter. Board completely, the value of I, the value of j, and which character you are looking for. Is this correct? So this is a function called which determines the 3 conditions. What are those 3 conditions? First one is row-wise uniqueness. Second condition is column-wise uniqueness. Third condition is 3x3 sub-boxes uniqueness. I hope you understood my point. So we will define it later on, but as of now, take it as a black box that there exists a function which is determining these 3 conditions. And if these conditions are true, in that case, what am I supposed to do? If this is true, Can I say I can insert in that scenario my value of board of ij as the value of c? Does everyone agrees with me?
Yeah.
Right? So far, so good, right? If we solve this board until next iteration, it will again go for the next particular number. We will keep on solving. And if it is fine, we will return it as a true. But at any point of time, let's say while doing this particular task of getting the value of c as 1, then 2, then 3, then 4, then 5, then 6, you stuck up in one situation where you will not able to solve this board. So what you will do in that case? You will backtrack. And when you backtrack, make the value of a board of ij as dot. This is important step to understand. This is where we are backtracking. This is the situation where you will not able to solve, you will not able to insert any number. And at that point of time, it means that from the very starting of the path, we have made some numbers wrong. That's why we stuck up in that situation, means that path is not correct. We need to backtrack from that path by replacing whatever values we have inserted with the value of c as dot. And finally, once we will move out of this for loop, when we complete our c values from 1 to 9, if let's say we are not returning as true answer, we will return the answer as false. And finally, after this complete for loop, we will return the result as true. I'm not sure whether the syntactically everything is fine. We will see if error will come. This is important to understand. How many of you, I think so far, these things you are following up with me. What I have done here, how many of you have understood? Anyone who can tell me what we have done here?
I have a question. Like, I understand what you're doing. Where is the exit condition here? Like, it's a recursion, right?
Think over
Because
it.
we're calling it. Okay.
Yeah. Think over it. Where is the exit condition?
I mean, the return false is the exit condition, I understand, but I'm intuitively not getting how we reach this. Uh, hmm. I mean, in earlier cases when we are using recursion,
This return
so we have
false
a
will
specific.
come when you will move out of this internal for loop. And this return will come when you will move out of this 2 for loops. I think now it is correct. Yeah. Let me just minimize it.
What is true then?
Now it is fine. Now it is fine. So when this will exit, it will start looping from value of 1, go 2, 3, 4, 5, 6, 7, 8, 9. Checking for every number, this valid condition. Writing that number if this is valid. After that, inside this if condition, once we are filling up value with C, we are checking if this solve of board have inserted this value as fine or not, if it is true or not. If yes, return true. Otherwise, if let's say this part is not true, this is false. In that case, it means that we are stuck up in that situation which just now I have shown you. This kind of situation where you have come up with 1, then while filling 4, you are stuck up with the situation, right? So in that case, you have to backtrack with that value of dot by making that one marked as dot. And finally, once you finish your entire thing of C, you can return the answer as false when you remove out of this for loop. Finally, if you will be able to scan the complete board that you have, you will return the result as true. One important thing which is still pending here is
Defining functions.
which function?
It's valid.
Sorry, valid and
Valid, solve.
is
This
valid and
particular
solve.
function is a black box, right?
Yes.
What this function is doing? I think some indentation issue is there. Let's see it later on. Okay. There is a board we have. There is a row value, row index we have, column index we have, C value we have, right? 3 conditions we need to check. For I in range until 9. So it will start from a 0 index. 1, 2, 3, 4, 5, 6, 7, 8. First of all, let's check it out. In the entire row wise, if my board of I, let's say column will be fixed. If at any point of time, this value is equal to C, what should I do? Is this a valid condition? In my entire row that I have, if there exists already a value C, is that a valid condition? Should I return true or false?
False.
False.
I'll return the result as false. First condition. Second condition would be, if my board of, now what I will do? I will keep my row fixed and I'll scan my entire column because I have to check the column as well. If it is equal to C, in that case again, I'll return the result as false. Third condition. This is interesting now, again. We need to somehow jump towards the indexes. For example, where I have mentioned the index numbers. We need to somehow check it out, the subbox's index number, right? For example, this is 0, 0. This is 0, 3. This is 3, 0. And this is 3, 3. This is, for example, 6, 6, 6, 8, 8, 8, 8, 6. So how we will be able to get this kind of a subboxes index?
Modulus 3.
So there is a way, basically row number and the column number, we need to figure it out, right? Row number and the column number. So what I will do is I will say board, check this and then think over it, what I'm saying here. I'm saying three times, whatever be the row value you have, divide by 3 plus I divided by 3. This is my row number I'm referring. And my column number, which I'm referring it as 3 into, again, column divided by 3 plus I modulus 3. Think over it, what I have done. I'm saying this is the way to get the index number of that subbox. That is true, that value is available in that subboxes. Return again false. Otherwise, when you move out of this for loop, return true. Now just work upon this condition. Very interesting, very important, which will also be helpful in solving upcoming questions of 2D metrics also. What I have done, why I have multiplied with 3? Why I have multiplied with 3 and divided by the row number and the column number index as 3? Any answer? For example, let's work upon this thing. What is the row number for this 2 value? What is the row number? It is 6. It is 6. What is the column number? It is also 6. So what we have done? 3 into row divided by 3. So what is the value we will be able to get?
2.
2. So 3 into 2 plus I divided by 3. What is the value of I? For
6.
example, huh?
I should be 6, no?
What is the value of I?
The value
Let's-
itself.
The value
Present.
itself, sorry. The value itself.
Exactly. Let me do one thing. Let's try to scan it step by step so that you guys will not get confused. Let me take this particular thing as the code and then not this one. Okay. Let's try to work upon this thing, what we are doing. So here we will be having 0, 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, and 8. Let's say I'm writing here number as 4. Okay. Now I need to check whether this number is available in the row wise, column wise, and in this particular sub box. Okay. That is what my major task to check it out. Let's work upon. So what is the row number here which I am working upon to fill the value of 4? 0. What is the column number here? It will be 2. Yes. So for I in range 9, so basically initially my value of I will be 0. So board of 0 and the column number 2, 0, 2. Is that value 4 is available? Is that value 4 is available? No. So here I will not return the answer as false. Now row of I. What is the value of row? It is 0. So with respect to this particular value, again I am scanning. The value of I will start from 0, then will go to 1, 2, 3, 4, 5, 6, and so on. So basically, initially I have scanned, fixing my value of column as 2, I equal to 0 to all the values that I have, because I have made a for loop which will start from 0, will go until the value of 8. In the second test case, what I have done is I have tried to fix my value of row, which is 0. And now I have checked for all the values. Is this 4 is available? So I value will start from 0, will go until the value of 8. So again, 4 is not available. So it is not returning me the answer as false. Now let's move ahead. Now I have to scan this complete, this box, orange box wala part. So what will happen? How will I scan? That is the important thing. Let's try to see what we are doing. 3 into row by 3. So what is the value of row? It is 0. 0 by 3 is 0 by 3 is 0. 3 into 0 is 0 plus I divided by 3. Initially my value of I will become 0. 0 by 3 is 0. So I am working upon 0, and then again for the column 2 by 3, 3 into 2 by 3. What is the value? 2 by 3 is 3 into, what is the value of 2 by 3 plus 0 modulus 3. What we will be able to get with respect to this number? Tell me.
2.
What is the value of 2 by 3?
Something 0.66.
So what this number will return to me?
0.
1.2.
What this division double divide operator will do?
Low division will
Sorry.
give
Yeah, it's
a real
3.
3. It will return 3.
No, 0.
Yes.
Return 0.
Come on, guys. This much inaccuracy I don't want in the class. Think over it again. Many people are saying 6. 6 answer will return.
2 floor division 3 will return 0, man.
Exactly. It will return the lower bound. So 2 divided by 3 is 0 point something, which will return you the answer is 0. 3 into 0 plus 0 modulus 3 is again 0. So what you are doing, you are taking this number, right? So you are saying 0, 0. Is this board of 0, 0 is equal to C? No, it's not the same. What will happen now? Your I value will become 1. Check for the I value equal to 1. What is the value? Tell me the answer. Do the calculation. Mathematical thing is there. Tell me. You have your value of row as 0, column as 2, I value is 1. What is your row index? What is your column index you will be able to get? Can anyone tell me now? Do the calculation. Again, 0 by 3 is 0. 3 into 0 is 0. Plus 1 divided by 3, what you will be able to get as the answer?
0.
0.
0.
3 into column by 3. So 2 by 3, again 0. Plus
0.
1 modulus 3 is? Now it's modulus. So 1 modulus 3 is?
0.
1.
1.
Modulus will give you the remainder. Divide will give you the lower bound of that value, whatever you will
Yes.
be able to get. So can you see? There is a shift from 0, 0 to 0, 1. Again, you're checking that whether 4 is available or not. Let's move ahead to the value of I as 2. Again, check what we will be able to get now for the value of I as 2. Again, check. 3 into, again, this value will be 0 only, plus 2 divided by 3. What is the answer? 0. 3 into 2 divided by 3 is 0, plus 2 modulus 3 is 2. So can you see? There is a shift from 0 to 2. 5, 3, 4. Let's move ahead to the next value when the value of I will become 3. So what will happen? 3 into, again 0 by 3 is 0, plus 3 divided by 3 is? 3 divided by 3 is? Can I say 1?
1.
Now we jump towards the first row. Let's see the column index. So 3 into, again, column by 3, it will be 0, plus 3 modulus 3 is 0. So we move to the 6th number. Again, when you see, you are scanning this, then this, then this, then this, then this. So this particular formula of row index and the column index, by mentioning this I divided by 3 in the first row part and I modulus 3 in the second column index part, will give you a scanning of this 3 cross 3 matrix. Why here I have mentioned 3 everywhere? The simple reason is that we are here scanning 3 cross 3 sub boxes at every point of time. If in future someone will say that I have created a Sudoku where you will have to scan 4 cross 4 sub boxes. As of now, it's not feasible. But let's say they have, designed some new Sudoku solver and they are saying that now it's not 9 cross 9. Maybe it's 16 cross 16. Anything can happen. They can manipulate just to check it out that whether you are good with the logics or not. At that point of time, you have to change again the logical part. But this thing will always help you out. The column index is modulus and this row index is division. Even in one another question, which we will discuss in the upcoming week, same knowledge will be helpful. So again, in that session, I'll ask from you and I'll test you out that whether you, got these points very clearly or not. Yes. Now, is this clear how this is valid function is working upon? Any confusion anyone is having? So how this I value is changing and how this I value will help me to give the particular index number. First condition, second condition, and third condition. This third condition is somewhat confusing, but if you will go very easily, very smoothly, step by step to scan all these elements, you will be able to understand what I'm trying to convey here. Any doubt? Shall I try to dry run again?
So the first condition is going through the entire column, right? 0 to 8. And then the second is 0 to 8 row wise.
Wait. First condition. What will happen in first condition? It will scan the entire columns or entire rows.
Entire columns.
Think over it. Entire columns or entire rows? Again, I am asking.
Rows.
Value of I is changing, right? Column is fixed. You are saying column is 2. Fix this column, 2. I value will change, no? I value will change
Yes,
from
yes.
0 to 8. So you will start 0, then 1, then 2. What thing is changing here? Row
Rows.
or column?
Rows are changing.
Rows are changing. So first condition is checking your row part. Second condition, you are fixing your row number as 0 and you are saying, now I will change the column. Always remember in
got
2D array, I told you also in the initial part when I explained the 2D array part. For example, this matrix is board, right? This is what we are naming. So board of, for example, if I am saying 1 and 0. So first index represents a row index. And second index indicates a column index. Right? So in this case, row variable I'm fixing as 0 means row will remain same. My value of I is changing, which is a column index. So I will move to 0 column, 1 column, 2 column, 3 column, 4 column, 5, 6, 7, 8. This is what my for loop is doing. And then here I am changing both rows and columns as per this 3 cross 3 submatrix. Still any doubt? Anyone? Okay, let's try to run this code. If there is any issue, we will try to first of all, remove that issue and then we will see. Let's try to call our function solve of board. Okay, it's working fine for one test case. Let's try to see for all other test cases. Working fine. Okay. Now tell me, any issue you guys have? These codes requires genuinely a lot of attention, a lot of time. And in the initial phase, please try to dry run these codes step by step. When you are at your home, one step at a time. When I started doing these kind of questions, if you can see, this is a hard level problem, right? In lead code. All the maximum problems with respect to this backtracking, which are available, even for DP as well, it's a hard level problems. So it genuinely requires a time and effort to think over it. It's not very easy problem solvable, right? So think over it, but if you will understand the logic pretty well, what we are trying to do, what every line of the code, trying to convey, it's very easy to understand by saying that it's not difficult. If you will see, whether you find it difficult, I don't think it's difficult. We cannot say it's very difficult problem. By saying it hard, it's not difficult. It's just requires a bit conscious efforts to take it, think it, and then write the code step by step. For example, sometimes you feel that a big lines of code will be there with respect to these kind of questions. Don't get afraid. What usually happens is people get afraid by, first of all, looking into these kind of explanations, they get afraid. Then by looking into these kind of codes, they get afraid. But if you will have a habit of, understanding the problem very clearly firstly, thinking the logic, writing it down, then running the code, it will be very easy for you. One important thing is, at your home, try to, see this website of pythontutor.com. I'll share with you. So what you can do on this website at your home? Usually we do a debugging in the Visual Studio. Maybe in the later part of our live sessions, I will try to, explain to you how we can do a debugging also. But as of now, in the very starting, these kind of codes specifically requires each and every step, how it is happening. For example, if I copy the same code, which we have written it down, let me just copy it down in this platform. But one thing is here, we need to enter the driver code as well. Okay. So what you're supposed to do is just mention this list of list, which is given in our lead code platform in the board part, and then call this function out, solve Sudoku, pass this board value that you have, right? And then for row in all the board that we have, we can print our row values, because this is not something which is we usually write in our lead code platform. Even you can remove this and just write board here. There might be indentation issue, which we will get now again. Let's see. Visualize execution, just run upon this. It's running fine, right? It's running fine. See, what you're supposed to do now, just listen this very carefully. This you're supposed to do at your home, not now, because this will require a lot of time. Now, everyone has its own pace of understanding. According to that pace, open in your system, copy the code, and just even you can try this for any code. Wherever you feel like that, there is something which is not working fine, or there is too much code, you won't be able to understand in dry running part how it is working upon. So I have just copied it down. Just now, whatever code we have written, I have just copied it down. Click on next. Can you see on the right side of the screen, visualization coming up? So here, next. So it is taking every row it is taking up, right? Solve Sudoku board. Now it is going to my main function, which I have defined. Solve board. Now it is checking the is valid condition. Going again to the solve board, recursion is there, right? Backtracking is there. So again, it will be checking for I, for j, if board of ij is empty. So in the initial part, if you will be able to observe, the value of I is 0, the value of j is 0. So it is not empty. So it will not go inside this condition. Again, it will check. Just see the right side. Don't focus on the left side. See the right side visualization part. Yeah, your value of j is now changed to 1, obviously, right? I will remain fixed. That's how the nested for loop will work. J will keep on changing from value of 0 to 8. So j value will become 1. Again, it will check. What is the value available at 0, 1? It is 3. So it is not empty. It will again go back. J value will become 2. Now, if you will be able to observe, it will be empty. That's why it is going inside the for loop. Now what it will do? It will check is valid. Can you see? For the value of c equals to 1, it is checking it out. Is this valid or not? Now it will go value of I. Can you see? It will be 0. It will check board of I column, row I, and this particular part. It will keep on checking these 3 conditions. And if these 3 conditions will be working fine. Now here, if you will be able to observe, we have 9 numbers, right? It will go 9 times, it will run, and 9 times it will iterate for the value of I equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And finally, can you see 1 will be entered up? This is one of the path. So at your home, try to, work upon all the situations, all the kind of circumstances with respect to this board, which we will be able to get. That's kind of thing which I was trying to visualize it here. You can visualize it, how via dry running, how this code is working. This value is coming up. Initially, what is happening when it is failing up at that point of time, how it is returning back as false, and then making it as from this one, making it as empty, which is dot, and then choosing that path where the value is 4. Choosing that path where the value is 4. This is the complete idea. Please make sure you will try to do it at your home. Okay. Yashasvi, if you want to leave, it's okay. You can leave. I think this is the only thing which we will cover up in today's class. This is enough. This is the idea which I want to convey. After that, I'll give one problem to each and everyone. I'll explain that problem statement before leaving the session, because I don't want anyone to be confused in the problem statement itself. And I'll try to explain to them how will that be done. And then I'll give them as an assignment to solve at their home. That's the only thing which we will do in today's class.
Ma'am, how to write that mathematical expression on our own while solving problems?
This particular mathematical part which you are talking about, I think this is what you're talking about, right? This one.
Yes, ma'am.
Majorly, this requires, a practice. This on the very first spot, if you didn't have looked upon and worked upon, you will not able to get a clear-cut idea that how basically I will scan these particular items in the 3x3 sub boxes until or unless you are pro in mathematics. Those people who have done maybe masters specifically in maths or stats, it's very easy for them to get the intuition of these things, which is taking time for us to understand and doing it manually side by side. But for you guys, or for me as well, who have not been pro in mathematical part, we people required a practice. We people required to solve a variety of problems, so that now in future, if similar kind of problem will come, you definitely get that intuition because you already have worked upon this problem. For the first time, you have to first of all refer it somewhere. Then only you will be able to get this intuition. Otherwise, it's not feasible for the first time to get the intuition automatically. This is not a magic, right? This is an intuition which we have to develop after practicing the problems.
Ma'am,
Okay, Saket?
is this the efficient approach of this particular problem, or
what I told you, backtracking doesn't give us an efficient approach. It simply explores all the possible paths. It is simply exploring all the values from 1 to 9. It doesn't care about the efficiency. So if I'll ask you now, from this one interesting question came into picture. What is the complexity of this code? Anyone who can give me the answer?
O of n cube?
O of n cube. Is that so?
No.
No, it's 2 to the power n, like it's exponential, right?
2 ki power n. Okay. Okay. Any other answer?
Not order of n cube, ma'am.
Order of n cube. Any other answer? So
I'm
two
taking a
answers I
guess.
got. One
I'm taking a
answer
guess
is
here.
2 ki power n.
Is it 9?
Second answer is n cube.
No, no. I think it is n square.
Oh.
N square. Okay. Any other answer?
Is it 9 exponential, like 9 to the power or something?
9 to
I
the
don't
power
know.
n.
I'm guessing it's not last one.
Out of these, only one answer is correct. I'll not tell what is the one. This is your assignment. Explore today and let me know what is the correct answer out of these 4 options. Okay? This is your task. Exploring all the possible paths, moving from 1 to 9. Given this is the loop, recursion is also there. Think over it. This is the actual test of you all with respect to the time, as well as think about the space complexity also. Okay? We'll discuss it in the next class. Apart from this, the next important and interesting assignment. So I think this is one of the most challenging assignments so far, which I'm providing to you, whether in terms of complexity aspect or in terms of giving you the problem. So there will be a reward for this assignment, which I am giving to you, because today is the challenging one. So there should be some good reward also with respect to the same. So what is the reward? I am planning to, give on Monday, whichever person will give me a appropriate answer with respect to this problem and the complexity with the explanation part. I'm planning to give them access. I have one course with the name of the Complete Excel Mastery course. If anyone is not aware, go and check it out on the website. So I believe Excel is something which everyone should know, and it's worth rupees, I think 1499 if I'm not wrong. As of now, the coupon code is going on with respect to the Republic Day sale, but it's about that much cost. So I'll give that one student the free access to that course. That's what I'm planning. Because this is challenging, that's why that reward. For the next upcoming challenging questions or problems, there will be a different reward. But as of now, this is the reward for that student. I don't know who is the one, but whosoever be the one, if maybe there will be no one, maybe there will be only one, maybe there will be two, maybe there will be three, I'm not sure. For them, this is the reward, okay? Try to see the problem statement, what it is saying. It is saying n queens puzzle is the problem of placing n queens on n cross n chessboard such that no two queens attack each other. Okay? Again, it's a kind of a chess problem where you have to make sure, for example, the value of n is 4. So in whatsoever possibilities, this queen will be placed so that there will be conditions that we have. Again, we will be having 3 conditions. First condition, row-wise, 2 queens can't sit with each other. Column-wise, no 2 queens sit with each other. Diagonal-wise also, they can't sit with each other. For example, here if you will be able to see, each solution contains a distinct board configuration of n queens placement, where q and dot both indicates a queen and empty space. There should be a constraint mentioning. Okay, they have not mentioned. But this is what they have mentioned. No 2 queens attack each other. That's the only possibility I have told you. 3 possibilities of attacking. Either they can attack row-wise or column-wise or diagonal-wise. Similar kind of a problem. Just like Sudoku solver, we have to explore all the possible paths, row-wise, column-wise, but here diagonal came into picture. In that situation, diagonal was not there. The third condition was to check in the sub-boxes. Here, the condition was to check diagonally. And at any point of time, these 3 possibilities will not be there. So how many possible arrangements of those 4 queens can be done? So for example, if you will explore all the possible paths of placing the queens, you will get that there are only 2 possible paths. So the answer is coming out to be 2. For 1, it is only 1. When we will be having a single queen, the answer is this. For the 4 queens, these are the possible 2 possibilities that we have. So you need to again explore all the possible paths. For every path possibility, you need to check, is that valid or not? Or is that safe or not? You can create one separate function of is valid or is safe. Try to implement that code, the 3 conditions, and then you need to return the final answer in the form of a list of lists, which contains a possible suitable arrangements of the queen that we have in our complete 4x4 matrix of a chessboard. Is that clear? What I'm trying to convey here? Any doubt on the problem statement, anyone? Again, if you will be able to observe, it's a hard level problem, very famous problem of n queens. You can refer the codes, it's completely fine. But what I'm really looking for in the Monday's lectures is that the way Arjit today have explained the mindset regarding that peak element finding solution, I'm looking for that kind of a mindset, that for every particular step that we are doing, why we are doing so, what actually we will be able to get from that step. If let's say you have mentioned one function by the name of is valid or is safe, In that, if you're providing 3 conditions or 4 conditions, what actually those 4 conditions are doing, what is the intuition behind writing that values. For example, here I have mentioned this condition. I have given you the complete idea behind this condition. Similarly, you need to give me a condition of checking the diagonal elements, of checking the row elements, row wise, column wise. I think that will remain the same only. But anyhow, for all the conditions, give me a proper justification of why and how we are doing so. Okay? And then at the very end, looking for a time and the space complexity aspect for the same. For both the problems, again, I am repeating time and space complexity. Second thing is you need to implement this particular question. It's a hard level challenge problem. For that, I have already told you what is the reward, and I'm looking forward to the solution for the same. Is that fine for everyone? Any doubt? Anyone? And then we will discuss in the next class. First of all, in the very starting, this problem only. And after that, we will start our upcoming discussion on the divide and conquer lecture. So if you are still here and have watched the entire video completely of that much long hours, so I believe that you really enjoyed it, and you must have understood till so far that how the backtracking concept actually works. I have given the assignment problem of n queens to the students who are there with me in the live classes. So the same thing will goes for you. Please try to make an attempt. In my sessions, there are students who made a very brilliant attempt towards that. I'm looking forward for your response also in the comment section. Please do let me know whether you will be able to successfully complete that n queens problem or not. With this, bye-bye everyone, and I'll see you all very soon in the upcoming video where we will discuss another amazing concepts of DS and data science. Bye-bye and see ya.